Hey everyone, and welcome to today's video. In this episode, we're exploring one of humanity's most enduring questions. Are we alone in the universe, or do other intelligent life forms exist somewhere out there among the stars? Since ancient times, this mystery has captivated philosophers, scientists, and everyday stargazers alike. We'll delve into a range of scientific theories, paradoxes, and speculative ideas about alien civilizations. Everything from radio telescopes scanning the skies to possible cosmic visitors from the distant past. Buckle up and let's journey into the depths of space and possibility, a universe of unimaginable scale. Our first step is to confront the sheer vastness of the universe. According to current estimates, the universe is around 13.8 billion years old. The diameter of the observable portion alone measures over 90 billion light-years. To put that in perspective, 1 light-year corresponds to about 9.46 trillion kilometers. So even the smallest fraction of the cosmos can be mind-bogglingly huge. Within this immense expanse, there are billions of galaxies, each containing hundreds of billions of stars. It stands to reason that countless planetary systems must exist, potentially providing fertile ground for life to emerge. That leads many scientists to surmise that life, at least in some form, may be widespread across the universe. Yet the pressing question remains, if life is so abundant, why haven't we found indisputable evidence of extraterrestrial beings or their signals? The Drake equation, estimating cosmic company. One of the earliest attempts to quantify how many intelligent civilizations might exist in our galaxy is the Drake equation, formulated in 1961 by astronomer Frank Drake. It incorporates several factors: the rate at which stars form in the Milky Way, the fraction of those stars that have planetary systems, the average number of planets in each system that could potentially support life, the likelihood that life will actually develop on these planets, the probability that this life evolves into intelligent, conscious beings, the likelihood that such intelligent entities transmit detectable signals into space, the average length of time a civilization remains detectable through those signals. Depending on the values assigned to each variable, the final outcome can vary significantly, from practically zero civilizations to millions. While the Drake equation doesn't offer a definitive answer, it underscores a crucial idea. Even if only a small fraction of stars host life-bearing worlds, there could still be countless civilizations populating our galaxy. Searching the skies, the SETI project. One real-world endeavor inspired by the Drake equation is SETI, Search for Extraterrestrial Intelligence. SETI projects use large radio telescopes to hunt for artificially produced signals, like radio waves or laser pulses, that could indicate the presence of advanced alien life. The underlying assumption is that a civilization with technology similar to or beyond ours might utilize electromagnetic transmissions to communicate. However, despite decades of listening, we have yet to intercept a confirmed extraterrestrial broadcast. Some argue that we've only sampled a tiny fraction of the sky and the radio spectrum. Others point out that an advanced society may use different communication techniques we can't detect, or may choose not to broadcast at all. Regardless, scientists persist with these listening campaigns, hoping that eventually we'll be in the right place at the right time and tuned to the right frequency to catch a cosmic hello. Fermi's Paradox. Where is everybody? Physicist Enrico Fermi posed a simple yet profound question. If life should be common, why aren't we seeing it anywhere? This query is known as Fermi's Paradox, and it offers a variety of potential explanations. Self-destruction. Perhaps every technologically advanced civilization eventually destroys itself, whether through nuclear conflict, environmental catastrophe, or other existential threats, before it can engage in lasting interstellar communication. Technological rarity. It could be exceedingly difficult to develop starflight technology, or to build powerful transmitters that broadcast signals across light years. Deliberate isolation. Civilizations might decide to remain silent, avoiding contact for safety or ethical reasons, sometimes called the zoo hypothesis, implying they choose not to disturb us. Distance and time gaps. The vast distances between stars and the speed limit imposed by light mean signals can take thousands of years to arrive, and civilizations may rise and fall within that span. They already visited and left. Maybe aliens once explored our sector of the galaxy long before humans evolved, or their probes came and went unnoticed. Fermi's paradox remains unresolved. prompting us to wonder if cosmic life is so rare that we might be unique, or if we're just failing to look in the right places and ways. The rare Earth hypothesis. On the opposite end of optimism lies the rare Earth hypothesis, which suggests that while microbial life may be relatively common, complex life forms and intelligent civilizations like ours are extraordinarily unusual. Advocates point to Earth-specific advantages: a stable, middle-aged star, an ideal planetary distance for liquid water, a large moon to stabilize the planet's tilt, and a protective gas giant, Jupiter, that deflects dangerous cometary impacts. Additionally, Earth's magnetic field and plate tectonics have been crucial to its habitability over billions of years. Critics, however, counter that we're now discovering thousands of exoplanets, some of which exhibit Earth-like traits. They argue that conditions for life could arise far more often than previously thought. After all, we don't yet know how many recipes for life might be possible, and it's conceivable that life could develop under conditions quite different from those on Earth. Exoplanets, potential homes beyond our solar system. Since the 1990s, astronomers have confirmed thousands of exoplanets orbiting distant stars. Many lie in their star's so-called habitable zone, a range where temperatures might allow liquid water to exist on a planet's surface. These discoveries by missions like Kepler and TESS have revolutionized our sense of what's out there, revealing everything from scorching hot gas giants to rocky worlds that might closely resemble our own. The next step in this quest is the spectroscopic analysis of exoplanet atmospheres. Instruments like the James Webb Space Telescope are designed to detect chemical signatures, such as oxygen, ozone, or methane, that could be signs of biological activity. Within the coming years or decades, we may be able to glean whether any of these distant worlds harbor life, at least at a microbial level. UFOs, UAP, and conspiracy theories. No discussion about alien life is complete without addressing reports of UFOs, unidentified flying objects, or UAP, unidentified aerial phenomena. Stories of strange crafts, Roswell in 1947 being the classic example, continue to captivate the public imagination. Meanwhile, the U.S. Navy and other organizations have released videos suggesting objects with flight characteristics that are tough to explain. But so far, there's no definitive evidence these sightings are alien in origin. Some incidents may turn out to be undisclosed military technology, atmospheric anomalies, or even optical illusions. The secrecy surrounding certain military programs naturally fuels conspiracy theories suggesting hidden alien technology. Yet without hard data, the question remains unresolved, and remains a staple of science fiction and pop culture. Panspermia, seeds of life drifting through space? Another intriguing concept is panspermia, the hypothesis that microbial life could spread throughout the cosmos via comets, asteroids, or cosmic dust. Under this scenario, robust microorganisms could hitch a ride from one planetary system to another, potentially seeding a lifeless planet if conditions prove suitable. Evidence for panspermia is inconclusive. While scientists have discovered organic molecules, and occasionally water, within meteorites, we've yet to find conclusive proof of living microbes crossing interplanetary or interstellar space. Still, the possibility that life on Earth might have arrived from elsewhere remains a captivating idea, suggesting that the entire universe might be connected by drifting, microscopic seeds of life. Did they already visit? Ancient aliens and lost encounters. Some people argue that extraterrestrials visited Earth long ago, shaping ancient civilizations, an idea often referred to as ancient astronauts or paleo-contact theory. Proponents claim ancient architecture, like the Great Pyramids or the Nazca Lines, might be too advanced for the technology of the time, and must have involved alien intervention. However, mainstream archaeology and anthropology provide more terrestrial explanations. Early cultures had impressive mathematical knowledge, engineering skills, and vast manpower resources. With centuries of development, they built monumental structures that can be explained without invoking alien collaboration. As with many alien-related subjects, we lack definitive artifacts or recordings that undeniably point to extraterrestrial contact. First contact, how would humanity react? Suppose we do one day confirm the existence of an advanced alien civilization, perhaps via an unmistakable signal, or even by direct visitation. What would that mean for us? The potential ramifications are enormous and have inspired numerous sci-fi scenarios. Cultural shock, religious beliefs, philosophical frameworks, and political ideologies might be thrown into upheaval. Technological leap. If visiting aliens are far more advanced, they might share knowledge beyond our wildest understanding. Global cooperation or conflict. Faced with an external presence, Earth's nations might unite or compete fiercely for any advantage in dealing with the visitors. Resource negotiations. Aliens might come peacefully but be interested in Earth's resources, prompting complex diplomatic negotiations, panic and uncertainty. A less benevolent arrival, or simply fear of the unknown, could trigger widespread alarm and societal unrest. Until that day arrives, we can only speculate, but the mere possibility reminds us how transformative such an event could be for our civilization. A cosmic mystery with no final answer. Yet, despite decades of searching and countless hypotheses, we still lack a definitive proof of extraterrestrial intelligence. The enormity of the cosmos encourages some scientists to believe that life should be abundant. Paradoxically, the silence we've encountered so far suggests either life is sparse, or we're listening the wrong way. New telescopes, missions to potentially habitable moons in our solar system, and ongoing observational projects might one day settle this debate. For now, we remain both observers and explorers, inching closer to understanding the nature of life in the universe. The question, "Are we alone?" continues to inspire research across astronomy, biology, physics, and beyond. Whether the answer is yes or no, it's sure to redefine our place in the cosmos. Thank you for joining us on this adventure through the possibilities of cosmic life. If you enjoyed this video, please give it a thumbs up, subscribe to our channel, and share your thoughts in the comments. Do you believe aliens are out there? And if so, what do you think they might be like? Stay curious, and we'll see you next time.